Okay, now we want to talk about one of the most interesting aspects of expected value, which is the expected value for gambling. Now, this leads us to the concept of a fair game. A fair game is a game or situation in which the expected value, I mean, of the profit distribution is zero. That's what's called a fair game. It's also called a zero-sum game, if you've ever heard of that expression before. Now, I want to make a note. This is not the same thing as a fair experiment. We talked about fair experiments in Chapter 5. So in Chapter 5, we said, hey, if it's a fair experiment, then that means each outcome is equally likely. But that is not the same thing as what's going on here. This is something totally different. Well, not totally different. They're related, but it's not the same. So a fair game has an expected profit of zero. Very important, right? There's no gain or loss to the player or to the house. In other words, the mean of the profit is zero. And then elided with this, or joined up with this, is house edge. The house edge is the expected value of the profit for the house. Usually it's written as a percentage. All right, so we'll see how this works in this example, hopefully. All right, so we have a charity that's holding a raffle and it sells 1,000 tickets for $2 each. One of the tickets will be selected to win the grand prize of $1,000. Two other tickets will be selected to win consolation prizes of $50 each. Lovely. All right, so we're going to create a probability distribution for the player's profit, for the player, right? So we're going to look at this from the player's perspective, which we usually do, to be perfectly honest. We don't often think of ourselves as the house, as a general rule. Okay, so there's three outcomes. You could win big, you could win small, one of those consolation prizes, or, of course, you could lose, right? This is a gambling game. All right, now we want to figure out our profit. But for that, we want to remind ourselves that profit is revenue minus cost. So it's in gambling, it's called the winnings minus, and then the cost is something called the ante. Better box that up just to remind ourselves what that is. Okay, ante, that's Latin, by the way. That means before. So it's a prefix that means before in English, but it's actually a word that means before in English, right? But it comes from Latin. All right, so let's think about this. If you lose, your winnings are zero, and you paid an ante of $2 each. You can actually see the ante right here. That's your ante. That's what you paid to play. So that gives you a profit of 0 take away 2, which is negative $2. Now, if you win the big prize, you win $1,000. So it's tempting to say, oh, the profit's 1,000, but it's not. It's 1,000, that's your winnings, take away the $2 you paid to play. So the profit is actually $998. Similarly, the consolation prizes are $50, so 50 take away 2 is 48. Those are the profits. And if you want to write them down, you could say, 1,000 take away 2 is 998, something like that, just to kind of remind yourself how to do it. All right, so now we want to find the probabilities, because this isn't a complete probability distribution unless we have the probabilities. And to do this, we'll have to remember what we learned from Chapter 5. So these problems tend to be a bit tricky because you have to know Chapter 5 stuff in order to be able to figure this out. So Chapter 5 rules will help us find this. I shouldn't say rules, I mean it's just Chapter 5 in general. it's everything we learned about probability in Chapter 5. All right, well, this is a raffle, so raffles are particularly easy to figure out. So there's one ticket that's a grand prize winner, and they're selling 1,000 tickets. So if you look right here, they're selling 1,000 tickets. So one ticket is a winner out of 1,000. So that's 1 out of 1,000, which is 0.001 if you want it in decimal form, which you do. So if you want to be able to put this in StatCrunch, you want decimals. You want don't use fractions. All right, so now there's 2 tickets that are consolation prizes. So that's 2 out of 1,000, which is 0.002. And then all the remaining tickets are losers. Well, there's 1,000 tickets total. 1 winner, 2 other winners, 3 winners total. So there's 997 out of 1,000 losers. And there you have it. Okay, so a couple of things. One, I can prove to you that those values are correct. So there's 1 out of 1,000, 997 out of 1,000, and so on. 2 out of 1,000. Lovely. Next, we want to make a note to ourselves because it's an important note. You must use decimals if you're going to do this in StatCrunch. It won't do fractions. Fractions are no good. So note, use decimals for the P of X in StatCrunch. Right? StatCrunch needs to have decimals. It cannot handle the fractions, which is fine. We figured them out. It's not too difficult. All right, so we want to find that expected value. Speaking of which, now again, we could do this by hand. It's not particularly difficult. I mean, I can prove it to you. So here, you just take each profit times its probability. So 48 times 0.002 plus -1 times 0.997. Right? So 998 times 0.001, sorry, plus 48 times 0.002 plus -1 times 0.997. Oops, I mean -2. Geez, we were paying $2 to pay a ticket. There we go. It's -0.9. There you have it. All right, so let me go put this into StatCrunch. I mean, you can put it anywhere. It doesn't have to be any place in particular. So I'm going to put profit here. I'm going to put probability here. Okay, so you know what? I'm going to say profit for the raffle, so that way I know what I'm searching for here. Select I spelled it raffler. Okay, so 998, 440 or 48, excuse me, and -2. What I just messed up. 0.001, 0.002, 0.997. These values must be probabilities. You have to use decimal probabilities. I mean. All right, so stat calculators custom. The values are the profits for the raffle, and the weights are the probabilities, right? They're at the very end, you can see. It puts this list in the same order that it is in the table or in the chart. So, and there it is. The mean is -0.9. So if you like to find it by hand, lovely. If you want to find it with StatCrunch, great. No worries. All right, so the mean for the profit to the player, right, because that's what this was all set up on, is -0.9. Of course, that would be dollars. Now, what does this mean in practical terms? It means that each ticket sold is expected to lose 90 cents to the player. So each ticket sold is expected to lose 90 cents, so 0.90, for the player. Now I know what you're thinking. Well, you can't lose 90 cents. You either lose $2 or you win. Right. What's happening is that it averages out to that much. If you take the winners plus all the losers, it averages out to a loss of 90 cents for each ticket. Right? Each ticket is expected to lose 90 cents. That's it. Right? Okay, so then what if a player decides to buy 25 tickets? What is their profit? Well, you just multiply, right? So the expected profit for 25, here. And I see people doing this sometimes. You know, I'll buy a bunch of tickets. 25 tickets would be the expected profit for one. Profit for one ticket, and you just multiply it by 25. Simple as that. So we're going to take negative 0.90 and you multiply by 25. Negative 0.9 times 25, and we get negative 2250. So that person should be out around negative 2250. And it's not really about any one player. It's about how it averages out in the long run for all the players, right? So you're more in the hole if you buy more tickets, which is fine. Maybe it's for a good, it's a charity raffle. Maybe there's a good reason for doing it, but nevertheless, you shouldn't expect to win this way. All right, now what is the house edge? Well, the house edge is the expected value of the profit for the house. So let's think about this for a second. If the player is losing 90 cents a ticket, that means that the house is winning 90 cents a ticket. You see? So whatever the player loses, the house wins. So the house edge is the expected profit for the house, i.e. the casino or the charity raffle people, which would be positive 0.9. And they don't usually write it with a dollar sign like that. What they do is write it this way. The house edge is usually written as a percentage. They expect to make 90% of what is sold. Let me explain this just a little bit further so you can see what that happens, right? So look, you sold 1,000 tickets at $2 each, which means the money in is $2,000, right? Into the house, right? Into the house. Okay, but they pay out 1,000, 50, and 50, right? So they pay out $1,100 out to winners. What's left? What's left for the house to take home? So if you take 1,000 tickets each, this is the money into the house, then you pay out this much. The difference for the house and for the player is 2,000, take away 1,100, which is $900, right? 90% of the 1,000 tickets, right? So this is the money that's going home with the house. This is the take home for the house, right? And of course, this is a very simple example, but that's what's happening. 90% times 1,000 tickets, right? So 90 cents on the dollar for every 1,000 tickets makes 900, right? Ever see what it means now, right? It's like, oh, that's how it works, right? Right. So, and of course, the player's losing that, right? So that $900 is collectively lost by the players, and $1,100 is collectively won by all the players. But of course, only 3 people actually get the money, right? That's why this is 90 cents here, right? Collectively, all the players are eating that 90 cents a player, so that these 3 people can be big winners, and the house gains that 90%. So that's the amount that the charity gets to take home with them. So if you've ever done like a 50-50 raffle or something like that, this is how those work. Although 50-50s are actually even easier than this. 50-50, it's half of it goes home and half of it comes back. So if it was $2,000 in tickets, it'd be 1,000 and 1,000. So I didn't do that because it's boring, but hopefully you see now, like, oh, okay. If the house if the player loses 90 cents, the house wins 90 cents. So that's negative, this is positive. And then they just generally write it as a percentage. That's just how we do it for gambling. It means the house expects to make 90% of each of the ticket sales and be able to take that home with them in the form of profit. That 90% of those 1,000 tickets means $900 will be take home for that charity. Now, is this a fair game? Well, that's this is where you don't want to think about what you learned in chapter 5. Chapter 5 is all about fair experiments, right? And everything has to be equally likely. Fair games don't roll like that. That's not how fair games work. Fair games, it's all about the expected profit. It's not about the probabilities. So it's not about the probabilities. That's a B. Do not talk about the probabilities. They don't have any bearing on it. Well, I mean, they do bear on it insofar as the probabilities help you figure out the expected value. But it's all about that expected value. So this is not a fair game because the expected profit for the house and the player, neither one of these values is 0. A fair game would have this value be 0 and that value be 0. They would both be 0, right? So no, because the expected profit for either the player or the house is not 0. Right? A fair game, a zero-sum game, it'll be 0 for both parties. Right? For the player, it was negative zero point 0.9. For the house, it was positive zero point 0.9. Expected profit in a fair game, it's 0 and 0. Which you can imagine does not happen that often in a true gambling game. But the trick is that when you go to a casino, you want to play games that are closer to 0-0. Right? That's the goal. And there are some that are closer. Blackjack is one of them. That's a game that's closer to 50-50. Closer, and I don't mean 50-50 in probability, I mean a 50-50 even split of the profit. So 0 and 0 for the expected values. It's not there, but it's getting closer.